and welcome to Are We There Yet? Market Scale's online video podcast that focuses on the most exciting things happening in transportation today. My name is Grant Harrell, and as your host, I'll speak with the voices of today's most exciting transportation companies, from automotive to aviation, from supply chains to space travel, unlocking the voices of today's most exciting companies and truly discovering what's at the cutting edge of transportation technology today. Upcoming topics within the Are We There Yet podcast series include head-to-head autonomous vehicle racing, your own personal aircraft taxi service, drone delivery, robotic food delivery, ride sharing for kids, and a research and development center in outer space. I have to remind you again, this isn't Star Trek or Star Wars. This is Market Scale's Are We There Yet? And this is happening today. And speaking of today, we're very proud to have Martin Peryea with us here today, Chief Executive Officer and Chief Technology Officer of Jaunt Air Mobility. Martin served a distinguished 30-plus year career with Bell Helicopter Textron, as well as Triumph Aerospace Structures, and today is leading the way within the next generation of aviation, working within a mission to provide users with their own personal aircraft taxi service at a price very comparable to what you'd pay today for a rideshare or car service in just a fraction of the time through their ride in the sky. And so today, very excited to have Martin here with us. Martin, hello, and welcome to Are We There Yet?
Appreciate it.
Thank you so much.
Thank you for the invite.
You're very welcome. We're very proud to have you here and very excited today. And Martin, we'd love to just jump right into it.
Sure.
and ask you, as I know our audience is very anxious, personal piloted aircraft for safe, reliable, comfortable, economic travel in and around urban areas. Are we there yet?
Good question.
Sure.
Not quite yet.
Yes.
We are working hard to get us there. The entire aerospace industry is working towards the development of an all-electric, safe aircraft.
Great.
And so we do have a few more years of development work that needs to take place before we're there.
Understand.
Yes.
Well, that's exciting. It's exciting to know that we're on the horizon and getting closer every day, as I understand with the work that I know Jaunt Air Mobility is doing. A lot of our audience members out there are very familiar with helicopters and airplanes, of course, but this idea of a fixed wing rotorcraft powered electrically, is novel and very exciting to learn about. With you having served over 30 years at Bell Helicopter and really a leader within aviation, I think you'd be probably the best equipped expert, to talk to us a little bit about this idea of a rotorcraft combined with the fixed wing technologies and electric power as well, and why that's important. Would love to learn a little bit more about this hybrid aircraft that you're developing.
Yeah, sure. Yeah, so over the decades, fixed wing airplanes, conventional airplanes have, developed and have been optimized for cruise flight, flying over, large distances very efficiently. Helicopters have been optimized to take off and land vertically and have the ability to hover over a spot for an extended period of time. So you have two different types of, aircraft, airplanes that can fly great distances very efficiently, and helicopters that can lift and hover and maneuver in low-speed flight.
Okay.
And so what we've done at Jaunt Air Mobility is combine those attributes of a helicopter and a fixed-wing airplane to provide the greatest efficiency for an aircraft that can take off and land vertically.
Wow.
And actually cruise like an airplane and have the comfort levels of an airplane. The reason why we had to do such a thing is because of batteries.
Okay.
Battery technology has advanced quite a bit here in the last decade, thanks to the automobile industry with their push to develop these technologies with battery controllers. And so 6 years ago, it wasn't really feasible to develop an aircraft that could take off and land vertically just on batteries alone. Today, we can do that because of the battery technology, motor controller technologies. And so we have, developed a design configuration specifically to meet that, what we call urban air mobility, the ability to move people and cargo in and around city areas very efficiently, very safely, and more importantly, very quietly.
Okay.
Yeah, it's one of the unique features of an all-electric aircraft. It can operate very, very quiet.
Great.
Yeah.
Great, very good. Sounds like bringing, the advantages of each of those types of aircraft, and kind of putting it all together into what sounds like will be really an ideal form, of commuter transportation. So very exciting. I understand you mentioned the importance of the electric engine and no noise, which is amazing, especially thinking about urban travel. I know that, safety is a major advantage of the aircraft that you've designed as well. Can you tell us a little bit, more about some of those advantages on the safety side of things that I know are very important to recognize as well?
Yeah, absolutely. So as you know, airplanes have the ability to glide upon a power loss, and that occasionally happens. And the same with helicopters. They have a gliding principle called auto rotation.
Okay.
And so our aircraft, basically takes advantage of both the gliding capability and the auto rotation capability of both a fixed wing airplane and a helicopter.
Okay.
Some of the other, eVTOL configurations that you may have seen with multiple fans and rotors are a bit challenged when it comes to, providing that same level of safety because of the configuration of the aircraft itself.
Okay.
And so they have to overcome that limitation by adding in additional redundancy into those systems to provide the same level of safety. But unfortunately, pilots will become absent-minded, and they may run out of battery power in flight.
Sure.
And so they'll need that glide capability or auto rotation capability to get to the ground safely.
Great. Very good. Very great to hear you've thought ahead. You've found a solution for that. I know that's very important and great to learn about that as well. Would love to learn a little bit more as I shared. Spent over 30 years, a very distinguished career with Bell Helicopter Textron. I know I did some very exciting work with Triumph Aerospace Structures as well, and now of course Jaunt Air Mobility. Would love to get a little bit of the background about how you became involved with Jaunt after such a distinguished career, and kind of bringing a lot of those experiences and technologies together, as I understand it, to the project today.
Yeah, as we were talking earlier, I did graduate from Cornell University with a bachelor's in applied physics and a master's in aerospace engineering. And so I started my career as an engineer, and I had the fortunate advantage of working with NASA on a lot of programs, doing a lot of wind tunnel testing on advanced aircraft configurations. Yeah. And that kind of kept, with me throughout my career at Bell Helicopter, running engineering and their research organizations, and always had the love for technology and looking out to see what we could bring in today to improve, obviously transportation. Yeah. And so that interest, that desire to, develop these new technologies was there. And I left Bell Helicopter, joined Triumph Aerospace Structures, got involved in a new aircraft design program, which I saw through the certification activities. And meanwhile, there was a lot of work being done at NASA with trying to develop an electric aircraft. Yes. Mark Moore was one of those principals at NASA who eventually left NASA and joined Uber as Uber was pursuing the urban air mobility air taxi business. And Mark Moore gave me a call and said, "Hey, Martin, you need to really take notice here. There's some technology that you're aware of that could be, useful to integrate into a new aircraft design." And so I left Triumph and co-founded Jaunt Air Mobility with two other individuals to pursue, this new market.
Wow, how exciting, how exciting. Yeah. Is this idea of an aircraft that is a bit of a hybrid between a rotorcraft and kind of a traditional airplane as we know it, is this a relatively new idea? I know that you mentioned, had always kind of had an interest in kind of that next generation of aircraft. And so I'm very curious if kind of this idea of kind of bringing these technologies together is a relatively new idea, or if it's something that's been in development for a long time.
Compound aircraft have been around for a very long time. Back in the 60s, there was a lot of work done by various companies looking at compounded aircraft. And unfortunately, those aircraft really didn't make it to market for one reason or another. Okay. And so that's why you saw the more traditional airplanes to fulfill the airplane type role, and the helicopter to fill the helicopter role. Yeah. And tilt rotor design was a design that Bell Helicopter came up to try to bridge that gap between a traditional helicopter that can take off and land vertically and an airplane that can fly fast.
Okay.
Unfortunately, helicopters cannot fly fast due to the limitations. It's basically, physics prevents them from doing that.
Yes.
And so our particular aircraft design, capitalizes on the technologies of a helicopter, but we have the ability to slow down the main rotor, the lifting device in flight. And you can do that because of it's being powered by electric motors and the control of that system.
Okay.
And so we do have, patented technologies surrounding the ability to slow and unload a rotor in flight. And so it's something that they weren't able to do back in the 60s and the 70s because of other various, reasons. But we have, matured that technology and proven that technology with a demonstrator aircraft.
Very good.
Yeah.
Very good. How exciting. It really sounds like the timing is now, where a lot of these technologies integrating the electrical engine sounds like an important part of that as well, are really coming together to once and for all enable all this to happen.
It is. It's really an exciting time right now in the entire aerospace industry. It's the next evolution in aerospace. You can kind of think of the evolution from going from internal combustion engines on airplanes to the jet engine.
Okay.
That was a big transition, going from, propeller-driven type airplanes to, jet engines to turbofan engines. And it changed the configuration of aircraft and the utility of those aircraft. And that's happening right now with the electrification of aircraft.
Okay.
And so you'll see, some unique aircraft designs because the electrification of the aircraft itself lends itself towards other configurations and different markets.
Okay. Very good. Well, that's a perfect lead into something I've been very curious about. I know I mentioned, of course, the personal taxi service, which was exciting in urban areas such as we're here today at Market Scale, 53rd floor. This idea of kind of commuting around urban areas. A trip to Fort Worth, for example, which we do often, and can get bogged down by traffic, of course. And depending upon the time of day. So that application is exciting, for many of us out there. But I understand we're certainly not limited to that, and there's a lot of applications, medical, public services, for example, already in the works. Can you tell us a little bit about, some of those ideas and applications that you have for your aircraft in the future?
Yeah, this new family of aircraft are really designed to service, cities in the urban area specifically.
Okay.
And so they're designed to be very, very quiet. One of the issues surrounding, helicopters today is the noise. And, people don't want noisy aircraft flying overhead. So we've addressed that with the particular design of the aircraft. And so they will serve the urban area. And of course, a lot of cities are becoming more and more congested throughout, America and of course, overseas.
Sure.
And you can't build more infrastructure, highways. You're pretty much already, maxed out where you can build highways in and around cities. And so to overcome that problem and to reduce, carbon emission, these electric aircraft will serve that purpose. And when you remove a car from the highway, not only do you remove the emissions, but you actually improve the throughput on the highway itself.
Okay.
So you get a 2-for-1 in that process. And so you'll be able to, transport people like from Dallas to Fort Worth, for example. You can do that trip in 20 minutes.
Okay.
Basically for the cost of a Uber car ride.
Incredible.
It is, and you can go, downtown to downtown, and provide that taxi service to the general public.
Sure. Sure.
In addition, there's other, missions for emergency medical services, EMS services, that are available, news reporting and police activity, things, associated with the general public and municipal services that can be made available.
Wow.
So there's that aspect of it, but then there's the cargo aspect of it. We have a couple of big Amazon delivery centers here in the Metroplex, one north and south. And, Amazon has to move packages back and forth between those delivery centers, and that's trucks on the road.
Yes.
And so you can set up these aircraft to fly, back and forth between these distribution centers to move cargo. And you can do that all night long. And, the sleeping public won't even hear the aircraft flying overhead.
Wow.
And so it does take, these vehicles off the road to obviously improve traffic.
Sure,
Yeah.
sure. Very good.
Yeah.
I understand as you've shared with us today that the electronic engine component of it is important. It enables some of the capabilities of the aircraft itself. But I also understand that your organization is very focused on sustainability, is very environmentally conscious. And I know that in addition to some of the technology and applications, that's important to Jaunt Air Mobility. Do you mind speaking to that a little bit more?
Absolutely.
Yeah.
So we do have a sustainable platform. We're using some advanced materials, what they call thermoplastics, to build the airframe. Unlike traditional composite material that you see today in aircraft, this material is recyclable. You can reuse this particular material.
Great.
Most of your composite material that are used in aircraft today, you cannot recycle that.
Okay.
And so, it ends up in a landfill. So all of our aircraft, including the battery system on the aircraft, can be recycled and put into other uses once the aircraft has, retired from life.
Okay.
Obviously, we're flying an all-electric aircraft, and so there is no, carbon emissions associated with flight operations. And depending on, your power source, whether it comes from wind energy or solar energy, it can be truly a sustainable ecosystem that we're developing right now.
Wow.
Yeah.
Well, that's great. Great.
It is.
Leading the way in sustainability and a really just a great demonstration. I think of where electric engine technology is today, and we've seen a lot happening within the automotive space, but seeing this now expand into aviation, I think is especially exciting.
It is.
Is that part of it? It's incredible for me to imagine that this type of service can be provided at a cost very similar to what we pay today for ride sharing or for car shuttle service and things like that. Can you speak just in general terms a little bit about how that's allowed? The idea today of taking a helicopter, for example, to Fort Worth, there would be a pretty significant cost associated with that, and you've really overcome that, with your service, with the aircraft that you're developing. Do you mind speaking a little bit to how that's achieved?
Yes, absolutely. So, the cost of operations, from the operator perspective, is what it costs to maintain that aircraft. And maintaining an electric aircraft, electric motors, is relatively inexpensive compared to a traditional, gas turbine type engine, which is very expensive to procure, but also very expensive to maintain.
Okay.
We also are able to lower the cost of the aircraft because of the number of aircraft that we will be producing.
Okay.
And so we take advantage of the fact that we're mass producing, and so that does allow us to lower our manufacturing costs through automation and the use of the thermoplastic materials, which lend themselves towards automation. And so that greatly, reduces the acquisition costs. In addition, the reliability of these aircraft are extremely high, and so you'll be able to fly these aircraft much more than what you would typically fly a helicopter.
Okay.
So a helicopter may fly, 200 to 400 hours a year. We're looking at flying 2,000 hours a year.
Wow.
And so all of your fixed overhead costs is reduced, on a flight hour basis. And so that's how we're able to achieve the lower costs for the passenger.
Wow, how exciting.
Yeah.
Exciting when a technology like this that of course we're all very interested in and certainly look forward to using, but the idea of it being something that's so affordable is especially exciting to know that when this is here and available to start utilizing, that it'll be affordable for everyone to enjoy. So that's very exciting to hear.
Absolutely.
Yeah. I wanted to be sure to mention too, I know that just very recently here through AFWorks, your organization was one of 11 companies, as I understand, that were awarded funding within the high-speed vertical takeoff and landing program. Understand that's a crowdsourcing funding program through the United States Air Force, and a lot of major government agencies and organizations are involved. Would love to learn a little bit more about that award and what exactly that means for Jaunt.
Yeah, it's a pretty exciting program.
Yeah.
So the Air Force is seeing the need for this vertical takeoff, high-speed capability, and there's been technologies proposed in the past that were expensive type of technologies, and so the Air Force put a program together to capitalize on the technologies that are being developed right now. With this new evolution in aerospace around the electrification of aircraft. And so the Air Force put a proposal out there, and there were over 200 submittals, and Jaunt was selected because of our technology to fulfill that mission. Our technology scales up to very small aircraft to very large aircraft. And it does have that unique capability to take off and land very efficiently and then cruise like an airplane. And so the Air Force has put forth a three-phase program. We're in the phase one element of the program where we're doing conceptual designs and laying out program plans for phase two, which will go into a detailed design type activity. And then phase three is to build a full-scale prototype and demonstrate the technologies.
Great. Well, how exciting. Well, congratulations on that award. I know that means big things for Jaunt, and exciting to have some of those, very recognizable organizations, behind your efforts. So exciting to hear that. I know that, part of Jaunt's success and has really been tremendous success over the past couple of years is enabled through not only programs like this, but through a lot of the really industry-leading partners that you have, on board for the team. Market Scale, of course, is a business-to-business platform, and many of our audience members out there will be voices of many of those companies and supporters of those organizations. I'd love to give an opportunity, to provide, a chance for you to, speak to any of those organizations or groups that are, especially behind some of your efforts, with Jaunt, and at least a platform to, mention some of those organizations that you're collaborating with, if you'd like.
Right, I appreciate that. One of the unique features that we're doing on our particular program is actually teaming with some very distinguished aerospace companies, what we call tier one suppliers that supply a lot of components to the Boeings and the Airbuses and the major airlines. And so we are working with BAE. They're located in New York. And BAE is developing the battery system for the aircraft, the flight control computers and the battery, energy management systems, the software systems that control that. We're really happy to have them on board because of their experience, developing and certifying components for aircraft. In addition, we've teamed up with CAE, located up in Montreal. They provide training for pilots. So they build a lot of flight simulators, for example. And they also do a lot of work in the engineering development activities, providing all of the simulation capability that is required for pilots to really understand the aircraft before you build the aircraft. And so they're on board and providing that capability to us. We recently brought on a engineering services company, L&T Technical Services, with offices here, in fact, Dallas, and offices throughout the U.S. and a large team located in India, and they'll be helping us. Another company local here is Carbon. Carbon is developing a lot of thermoplastics technologies today that we're planning on utilizing on the airframe design of the aircraft. So that's just to mention just a few of them.
But I love it. What a team. What a team. It sounds like really the best and brightest within the industry that are teaming with you to make it happen. So it's really exciting to learn about. We're all anxiously awaiting the arrival of Jaunt Air Mobility and for the opportunity for us to all, get to enjoy the service. What's the target date right now for when, individual users such as myself might start planning that trip to Fort Worth, but looking forward to using the technology?
So we're looking at 2026. To have a certified aircraft, and we'll start, putting those aircraft into service. You may see some prototype aircraft flying in and around. but we can't take passengers in those particular aircraft.
Sure.
So 2026.
Sure. Very good. Well, 2026, that sounds great. I know we're all very excited for it. And again, just want to thank you so much, Martin, for your time today and for introducing us and the audience members to Jaunt Air Mobility. I know that we're really excited to start utilizing the service, and especially over the next couple of years, we'll definitely keep track of what's going on with Jaunt. Be very excited to learn of the new developments that you and the company are working on. So thank you so much for your time today, and best of luck with the company. So,
I appreciate it. Thank you very much.
You're welcome. Thank you, Martin.
Thank you.
Yes.
Yes.